Welcome everyone. Let's discuss another question from the GATE previous year questions. The question is the dissociation constant for a receptor-ligand pair is 0.25 into 10 raised power minus 7 molar. The ligand was added to a solution of the receptor such that the receptor was 50% saturated at equilibrium. Assume that the receptor has one ligand binding site. The concentration of the free ligand at equilibrium in nanomolar we need to report. Now, as we all know that the dissociation constant represents the ligand concentration at which 50% of the receptors are occupied by the ligand. So you have the R, receptor, ligand, and then you have RL complex. And the dissociation constant represents the ligand concentration at which 50% of the receptors are occupied by the ligand. So the Kd value is given 0.25 into 10 raised to power minus 7 molar. The ligand was added to a solution of the receptors as that mentioned already that the receptor was 50% saturated at equilibrium. So if something which is 50% bound, that means 50% is free. And that's what they have asked in the next part. Assume that the receptor has one ligand binding site. The concentration of the free ligand at equilibrium in nanomolar. So Kd value given is 0.25 into 10 raised to power minus 7 molar. And we all know this is 50% occupied. That means the 50% is free. And the concentration of the free ligand is going to be the same, which is 0.25 into 10 raised to power minus 7 molar. But since we need to report our answer in nanomolar and in the form of integer, so we'll are going to convert it into nanomolar. 0.25 into 10 raised to power minus 7. 1 molar is equal to 10 raised to power 9 nanomolar. And the answer is going to be 0.25 into 10 raised to power 2 nanomolar, but we need to mention it in the form of integer. So that means 25 nanomolar. So the answer is going to be 25 nanomolar. We need to be very careful with these conversions. I have just shown you a flow chart where, from the molar to the millimolar conversion, it requires the multiplication in a factor of 10 raised to power 3. Same for the millimolar to the micromolar. 1 millimolar is equal to 1000 micromolar, and same 1 micromolar to the 1 nanomolar requires the multiplication by the 10 raised to power 3. In a reverse way, if I'm going from 1 nanomolar to the micromolar, 1 nanomolar corresponds to 10 raised to power minus 3 micromolar. Similarly, 1 micromolar to the millimolar. Remember, the millimolar is a bigger unit. So 1 micromolar is equal to 10 raised to power minus 3 millimolar. If I have to move from here to nanomolar, what I'll do is I'll just consider all these numbers. 10 raised to power 3, 10 raised to power 3, which is 10 raised to power 6, and then 10 raised to power 9. So 1 molar is equal to 10 raised to power 9 nanomolar, or 1 nanomolar is equal to 10 raised to power minus 9 nanomolar. These conversions will help you in solving many of these numericals. I hope this question and the solution is clear to each and every one of you. If not, please answer it in the comment section. Thanks for watching the video.